Welcome to the Explainer. If you're working with data on AWS, then you know you've got a huge responsibility, protecting your users' sensitive information. So today, we're going to break down exactly how to do that using data masking and sanitization.
Here's what we've got on tap. We'll start with why protecting PII is so critical. Then we'll get into some really practical stuff like securing logs and sanitizing whole data sets. We'll also unpack dynamic masking and some key techniques you'll absolutely need to know. And hey, if you're studying for the Developer Associate exam, you're definitely going to want to stick around for this.
Okay, let's dive right in. Before we talk about how to protect data, we need to be crystal clear on what exactly we're trying to protect. So PII, it's more than just the obvious stuff like a social security number. The key phrase to burn into your brain for the exam is linked or linkable. Think about it. A name on its own, maybe not PII. But a name combined with a zip code? That's PII. An IP address? Yep, that's PII too. The scope here is so much broader than you might initially think.
And why is this such a big deal? Well, it's not just about ticking a box for compliance with regulations like GDPR or HIPAA. A data breach can completely shatter user trust, lead to massive fines, and it really just undermines the entire security of your application. Honestly, this is a core responsibility for anyone building on AWS.
All right, with that foundation set, let's tackle a classic developer nightmare, accidentally logging sensitive data.
This is a scenario that is practically guaranteed to show up on the exam. A user's login fails, and boom, your app logs the whole failed request, password and all, in plain text. Or maybe a payment API call fails, and now you have a full credit card number sitting in a stack trace. These are huge, glaring security holes.
So how do you stop this from happening without writing tons of custom filtering code in your app? Well, the good news is AWS has a powerful managed service designed for this exact problem. The solution is CloudWatch Logs Data Protection. And here's where the magic happens. It automatically detects and masks sensitive data as it's ingested. This means your developers can still debug the logs without ever seeing raw PII. Now, what if someone actually needs to see that unmasked data? Well, they'll need a very specific IAM permission, logs unmask. It's a fantastic, real-world example of the principle of least privilege. Okay, so we've handled logs, but what about a much bigger challenge? Like, how do you sanitize an entire production database so you can use it in a development environment? You can't just copy and paste that stuff.
Right. Before you can clean up the data, you have to find it. And if you've got a massive data lake in S3, hunting for PII manually is, well, it's just impossible. So how do you find those needles in that giant haystack?
This is a job for Amazon Macy. You can think of Macy as your PII discovery bloodhound for S3. It uses machine learning to scan all your buckets and tells you exactly where your sensitive data is hiding. It gives you the visibility you need to take that crucial next step. Okay, so Macy has done its job and pointed out the PII. What's next? How do we create a safe, sanitized copy for our dev and test environments? And remember, using real customer data in non-prod is a huge security no-no.
And this is where it gets really cool. You can build a completely automated serverless pipeline to handle this. Check it out. New data lands in S3, which triggers an event bridge rule. That kicks off a step functions workflow, which uses AWS Glue Data Brew to profile the data, find the PII, and then automatically apply masking or hashing transformations. The clean, sanitized data gets loaded into a totally different S3 bucket, ready and safe for your developers. The whole thing is completely hands-off.
So far, we've been talking about permanently changing data for things like logs or dev environments. But what if you need to show different versions of the same live data to different users? That, my friends, is where dynamic masking comes into play.
This is a really key concept for the exam. Encryption at rest protects the data on the disk. So if someone walks out with the physical hard drive, you're covered. But once an authorized user queries that data, they see everything. Dynamic data masking is totally different. It protects the data while it's being viewed. The actual data in the database never changes, but the database itself applies masking rules on the fly based on who's asking for the data. All right, here's another classic exam-style question for you. A customer support rep needs to see just the last 4 digits of an account number. Do you control this with an IAM policy, or do you have to write a bunch of custom if-else statements in your application code? And the answer is, it's a bit of a trick question. The best practice here is to handle this at the database level. Services like Amazon Redshift and Aurora actually have dynamic data masking built right in.
You can create a policy directly on the database table to handle this logic for you. And the best part? It keeps your application code clean and centralizes all your security rules where they belong.
Okay, to wrap this all up, let's quickly clarify two more key terms that you will almost certainly see on the exam: tokenization and pseudonymization.
Now, these terms sound pretty similar, and they are related, but there's a really important distinction that you need to get straight. At its core, pseudonymization is all about replacing sensitive data with a non-sensitive substitute. We often call this a token. So a real credit card number might get replaced with a totally random string of characters. The key here is that you can still use this token for things like data analysis or joining tables, without ever exposing the original PII.
And here it is, the crucial difference you need to know for the exam: reversibility. Anonymization is a one-way street. You strip out PII in a way that it can never be linked back to a specific person. Pseudonymization, on the other hand, is reversible, but only for authorized users. They have the key, so to speak, to map the token back to the original PII. That is the key distinction.
So let's put this all together in a quick little cheat sheet. If the exam asks you about sensitive data in your logs, your brain should immediately go to CloudWatch Logs. Discovering PII across S3, that's Amazon Mossy, hands down. Sanitizing a big data set, you're looking at AWS Glue Data Brew. And that real-time, role-based access, that's dynamic data masking in Redshift or Aurora.
We've covered protecting data at every single stage: when it's coming in, when it's sitting at rest, and when it's being used. Hopefully this gives you a really solid framework for crushing these questions on the exam, and more importantly, for building much more secure applications out in the real world. Thanks for joining us on The Explainer.